Welcome friends, I am Tanmay. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today I shall discuss about Cannizzaro reaction. Actually, this reaction is a redox reaction in organic compound, okay, where one molecule of aldehyde is oxidized and one is reduced. I will explain. So today's discussion will mainly focus on few points, means basic concept and alpha hydrogen, it's important. Second is mechanism. Third is rate of the reaction and its dependence on the concentration of alkali. Fourth, role of electron donating as well as electron withdrawing group. After that, I will discuss is intramolecular or intermolecular, because there could be a controversy. Is the reaction is intramolecular or intermolecular? So we will discuss this factor in this video. So let's start. So as you can see, the oxidation number of this benzaldehyde, it is in +1. Actually, I am taking benzaldehyde because one is as an example or discussion. Okay. So this benzaldehyde actually, first of all, this is +1 oxidation state, this carbon. And when this benzaldehyde is oxidized, the oxidation state of this carbon is +3. But when it is, means one is oxidized corresponding benzoate, means it's an alkali. So benzoic acid will not be there, it will be benzoate. And this part is oxidized. See, oxidation is +1 to +3 oxidized. Another from +1 to -1. This is reduced and this is benzyl alcohol. You can see one thing, 2 unit oxidation, 2 unit reduction happening in a same reaction. And that's why this reaction is called disproportionation. Actually, why? Because one unit is oxidized and one unit is reduced, and that is the definition of disproportionation reduction. So that's why this reaction is called disproportionation, because one is oxidized, one is reduced. Fine. And another one most important thing is that it should not have any alpha hydrogen. Question why? What will be the problem if we have any alpha hydrogen? The problem is that if we have alpha hydrogen, there is a chance of aldol condensation. I have explained aldol condensation and its mechanism through Burger-Unit trajectory. 2 separate videos uploaded. Please watch it, it will be helpful. So no alpha hydrogen means to avoid aldol condensation. Fine. So okay, we understood that 2 conditions needed. One is no alpha hydrogen and another is strong alkali is essential. Why strong alkali? Because if we take weak alkali, then it is true that reaction will occur but will not efficiently occur. Difference between aldol condensation under basic condition and the Cannizzaro reaction is that aldol condensation needs less concentrated base, or weak means less concentration of base is essential, but for Cannizzaro strong more amount of base is involved. Even it has a contribution, I will explain later. So this is the main difference under aldol condensation, that aldol needs weak means less concentration of base and needs strong concentration. Main reason is that the first step, that is an alpha proton abstraction of aldol condensation, is an acid base reaction. But here the alkali attacks nucleophile, that is a nucleophilic addition reaction, means actually it is a nucleophilic acyl substitution. It is nucleophilic acyl substitution. Okay, I'll explain. So during the mechanisms, that's why it is essential to have strong alkali concentration. Okay, fine. So let's go to the mechanism. Mechanism, what happens? First, these alkali attacks the carbonyl compound. Why? Because this is electron deficient, means it's a delta plus and it is delta minus. So since it's electron deficient, that's why alkali attacks. This alkali attacks in this position, it opens up. Fine. And another thing, we know that ketone is relatively less bulky as one part is hydrogen. So less bulky, so nucleophilic attack on ketone is relatively easier. So till now this is nucleophilic addition. I have told acyl substitution. Actually we should say type. I'll explain. So what's happened? Then after that, this is a reversible step, addition. So after that, one O- is generated and another thing, this OH is attached. Now this reacts with another molecule. As I told, 2 molecules of this aldehyde is essential for this reaction, and one is oxidized, one is reduced. Fine. So here this will push its electron And what will happen? One chance is that OH will leave. That is a simple static material, so no conversion. As I told you, it's reversible reaction, that will definitely happen. Another chance is that there is R and there is hydrogen. So R means R have no alpha hydrogen, means you can consider phenyl. But among these two, hydrogen has greater migratory aptitude. Consequently, it removes. Why I am saying migratory aptitude means which can leave. Hydrogen can leave better. And what happened? It goes and it attacks here. Similarly, it is electron deficient and it opens up under alkaline condition. So till now I am saying it's intermolecular. Accept it. I will prove it whether it is really intermolecular or intramolecular. So this is, and this migration, this is also a reversible reaction. So this is hydride shift or migration, whatever you say. Hydride migration. So this is hydride migration step. Fine. After that, what happens? You can see that this carbonyl is reduced. Fine, because hydride attack. Hydride is a reducing agent. So, and this is oxidized to corresponding carboxylic acid, and this is alkoxide minus. Now, as we know that alkoxides are stronger base compared to this proton. Actually, this is a very acidic. So, instantly a irreversible acid-base reaction will happen. This is acid-base reaction. Acid-base reaction will happen, and this will form this carboxylate, and this is alcohol, as I told. So, I guess you have understood the mechanism. Now, question: why this is nucleophilic acyl substitution? In nucleophilic acyl substitution, for example, if you take RCOCl, acetyl chloride, and nucleophile, for example, you can take alcohol. You can take alcohol, or even you can take cyanide, those whatever nucleophiles. It will attack first, and this opens up. What produces ultimately this step? O minus and this nucleophile. So this is the nucleophilic addition. After that, what happens? This pushes back and this chloride leaves to produce RCONU. That's why this is called nucleophilic acyl substitution. And here, like this chloride, hydride is playing as a role of leaving group and going and attack this carbon. Okay, so we have discussed about the mechanism. Now, rate of reaction and the concentration of alkali. See, here, what is the role of alkali? Alkali is first attacking the aldehyde carbonyl, and it producing a tetrahedral intermediate. So, this alkali's main role is the attack on the carbonyl. So, for this one equivalent alkali needed. Fine. So, one equivalent, and here for this, after one equivalent alkali, this reaction happens. So, actually here one equivalent of aldehyde needed, another second equivalent here. So, first the rate of reaction, what is expected? That is rate constant into aldehyde into alkali. Aldehyde needed 2, so it is 2. Now, question: if we have excess alkali, what is happening? It is observed in reality, increasing the concentration of alkali, the rate of reaction enhances. Question: how and why? So, after this reaction, you can see a OH is produced, and this is sufficiently acidic. So, alkali can do that. Alkali can abstract this and produce abstract. So, what it can produce? It can produce O minus, and H. So, here it's a dianion species. So, this dianion is dianion species. After that, these are dianion shoot this hydride, and which attacks here. Okay, fine. Now, if this is, then actually 2 alkali needed. So, in presence of excess alkali, the condition is, if it is excess alkali, then rate is K equal to aldehyde constant double and alkali also double. Okay, square. Fine. Now, question is how rate is enhanced. So, if you observe closely that previously one oxygen was pushing, hydride was leaving. Right now, both oxygen can push electron. Okay, both oxygen can push electron, right? So, probability of shifting it's become more efficient, and that's why this state became more facile, and this happens easier. So, I guess you have understood how role of alkali affects the concentration and rate of reaction. Rate of reaction is a physical phenomenon that you see that reaction happen very fast complete reaction happen. Question why? This is the explanation. Okay. Now we will discuss about the role of electron withdrawing and donating. Okay. So how this electron withdrawing group and donating group is affecting this reaction. Question, take this example, benzyl, and it's aromatic, so it could be one example. We can consider para position. This is CHO. I should write it original benzene form. This aldehyde, and for example, let's take nitro. And how nitro means this is looks like this, and this is O minus, nitrogen is plus. And how nitro happen? Because it withdraws electron here. For example, this pushes electron here, and this is opens. In this way, it acts as electron withdrawing effect. So it is electron deficient. So first step is nucleophilic attack, means it depends on the deficiency of this carbon. So that is also positive. That one unit positive, that attack is fast, attack is favored. Fine, very good. Second, in case of this shifting O minus, it is after this is the sp3 center tetraatom intermediate. So now the conjugation factor is not working here, so it will push. Fine, but its also accepting capability is more. First aldehyde is attacked by this hydroxyl, second is attacked by the hydride, that is also favored. So overall reaction favored, and in reality it is observed that in case of nitro derivatives, this electron withdrawing derivative, little less strong alkalis also can do the job. Okay, and another point is that if we take very strong alkali, then there is a chance of reduction of this nitro group. Okay, so this is the thing, means this will be done, but another influence of alkali, you have seen this nitro group is reduced, so that has another chance. Okay, fine. Now if it is electron donating group, for example, we can think that this is Me2. This is dialkylamine. This nitrogen has a lone pair. So what happens here? So if it is electron donating group, through this electron donation means here in this way, in the what it will push here, it will push here in this way open. So in this way, electron is pushed to the aldehyde. So consequently what happened? Electron deficiency of this carbon reduced. So if electron deficiency is reduced, it is not interested, or it will not that much hungry for this electron rich nucleophile. So nucleophilic attack will be hampered. First stage means -1. Second stage, this hydride shift will also be hampered. So reaction happening is difficult, and in reality these don't undergo reaction. Okay, so keep this factor in mind, that electron withdrawing group accelerate reaction, electron donating group it slows down, or sometimes it does not happen. Now we have discussed the role of electron. Now question is, the last one is intramolecular versus intermolecular. So I have already explained how intermolecular is working. So let's discuss about intramolecular, how intramolecular is working. And in this case instead of alkali, we will take alkoxide. This alkali was in water, aqueous medium reaction was. Now we will take alkoxide in alcohol. Okay, so let's see. So if we think in this way, for example, let's consider this one, this intermediate. After attack of this alkali, what it produced? This is R. This is R. And here, for example, you can consider this is a benzyl also. It will be helpful to compare. And if you confuse during the study, please go to the back slide where I have where mechanism was here. So this, and if it is intramolecular, then what can happen? Then these will first attack. Means these will attack this H. For example, this is pH. If it attacks here, what will be the product? Product will be pH. This is OH. This is O. This is O, and after attack it will be O minus, pH and H. Now what can happen? This can push back its electron, and consequently this hydride will go and attack here, and it will open up. Fine. So what will be product? pH, this is H as it is, this is another hydride shifted here, and this is OH, our product, and here this is pH, this hydride is shifted, this is double bond O, and this is O minus. Fine. So this is, you may think that but this doesn't happen. Why? And another thing you may confuse, why not this side? Because see, here oxygen is O minus, so electron is, so it can push the electron more, so hydride shifting is from this side, opposite side, we will not consider. Now, if we take this phenomena is wrong, would be proved by this alkoxide in alcohol. So if we take alkoxide, what will be the product? Alkoxide will be added here, means OR, and similarly, if it attacks to benzaldehyde, what will be the product? This attacking, so this will be O minus, this is pH, and this is H. Fine. So we have drawn. So now it will push electron. This hydride will shift at this position, and it will open up. Okay, so what is the product? This part, this alkoxide attached part is reduced to hydride attached. So this is pH, CH2, OR, this is OR, and here another product is pH, this part oxygen pushed, this hydride, so no hydride left, that is carboxylate anion. Fine, but let's consider according to this mechanism this. But what actually obtained, that doesn't contain this OR in the benzyl alcohol derivative. How? So pH first stage O minus, this is OR and this is H. Fine. After that what happened? It pushes his electron and hydride moves and attacks another molecule of benzaldehyde this way. So ultimately which part is reduced? It will produce the pH CH2OH finally, and it will produce pH COOR. So here ester is produced, and in reality this is produced. So this strategy is wrong, is proved by this example. So never be confused about this mechanism. Okay, so this is the end of today's discussion. In next video I shall explain about examples, which is important for understanding. Generally I recommend for high school student, means class 11 or 12, to watch mainly the basic part, means mechanism and understanding. But in this case, for this Cannizzaro reaction, I suggest student please watch the example videos. And another next video, next two video, one is example, another is cross-Cannizzaro. That both are very important, and Cannizzaro reaction is very important for all exams. So please see it. So this is the end of discussion. Thank you for watching my video. If you like my teaching, please give a like. Share this video among your friends such that many people could be benefited from my effort. And finally, please press the bell icon to get the notification of every single video. And of course, subscribe my channel, Chemistry, the Mystery of Molecule. See you in my next video.